Okay, so still on chapter 1 with the matter and measurement. Now we're getting into the measurement part of chemistry or matter. And buckle up, okay, because this one is going to be a little bit of an intense chapter because we're going to go through numbers a lot and some calculations as well. Okay, so first of all, let me mention to you that this is kind of one of the most fundamental things that you're going to do, okay, for chemistry, which is measurement, because all your calculations that you do, they all involve numbers, okay? So in this case, we're going to learn a lot about how to carry out those measurements, what are the units we use, what data is significant, like is everything going to be, does it matter, like this number, okay, those kind of things. So significant data, we will learn about that. We will learn about exponents in this one, okay. Data conversion is a big thing, okay, so you convert one data into another, from one unit to another unit. So all of that is important. Why is all of this important for us? Is because of that thing in the scientific method called experimentation. So when you do experimentation, you have to collect data. So when you collect data, you have to know what you're collecting. You have to know what units you're collecting in. Okay, so all of that becomes really critical. So this chapter or this portion of chapter 1 is really, really important for us. Okay, very fundamental. So first, let's talk about units. Okay, there are going to be two kinds of units that we talk about. First are called the SI unit and the other called non-SI units. The SI units are standardized units and they are followed by the entire world. And the non-SI units are not standardized and they are followed by the United States. And you have to think about at some point, why? Why is it that we don't follow the standardized units? And if you want to, you can email me and let me know what you think about that. Okay, I'm not going to answer that question over here. It's something for you to think about. Okay, so again, SI units are standardized units and the whole world uses them. Now, first of all, why do we need to have units? Okay, so if I say to you that I'm 50, then what are you going to think? And the first thing that comes to your mind, I'm thinking, is, oh, she's 50 years old. But I didn't say that. I just said I'm 50. I could also be 50 kilograms, right? I could be 50 pounds, which would be awesome, but not awesome. But still, I didn't tell you what to put after that 50. And that unit, okay, is what really classifies 50 and tells you a little bit more information about me, okay, at that point. So I'm 50 nothing, by the way, okay, that was just an example, but you understand the point, all right? So you can't just say that, this is 50. Well, what is 50? Okay, so units are used to express different kinds of things. So what are the things that we express? Here we are going to learn a few things, okay, not a whole lot, because we are limited in what we are doing. So for example, we can give qualifiers for weight, for length, time, temperature, volume, pressure. These are all the things that we are going to be studying in this semester. So these are all the units that we are going to learn about. These are the things, the qualities that we are learning. These are the qualities we are measuring, okay? So weight is measured in kilograms. So SI unit for weight is kilograms. The non-SI unit is pounds, ounces, and I've not written everything in here. Could be more also, okay? So depending on where you live, it could be something else as well. Length is measured in meters as far as SI unit is concerned, and then for non-SI it's miles and feet, and inches also and all that, right? So that's also there. Time is really standard. It's seconds and seconds for both, whether it's standard or non-standard, it doesn't matter. Temperature, we think that centigrade or Celsius is actually standard. It is not, okay? Kelvin is the standard unit for temperature, and Fahrenheit and Celsius or centigrade, you can use either one of those. Those are considered to be the non-SI units. For volume, liters is the SI unit, gallons, quarts, pints, all of the other stuff, liquid ounces, those are going to be the non-SI units. Pressure is newtons for SI, and then the non-SI is going to be all of these, okay? what I've also given to you over here, just so that you know, okay, because you're going to be working in lab at some point or another, and you need to know what kind of measuring device you use for all of these things. So for weight, you will use a balance or a scale. For length, you will use a measuring tape or a ruler. For time, everybody knows you have the clock, right? You have your phones with you and you can just do that. For temperature, you use a thermometer. What kind of thermometer? Is it digital? Is it mercury? What kind it is? So again, different kinds of thermometers, okay? And then graduate cylinder for volume. Now, volume, you have two different kinds of volumes, okay? The volume could be for a solid or for a liquid, and the volume that's mentioned over here is actually for liquids, okay? So that's the graduated cylinder, volumetric flasks. We have all of these things in the lab. You have it at home also, right? You mix, anybody who's ever baked something, you know that you need half a cup of something or, 1 cup oil. So you have liquid measurements. And then for pressure, it's barometer. Now, some of these devices you must have seen already, and some maybe you have not seen, and so it just depends, okay, what you have seen. But in the lab, you're going to use pretty much all of these things, okay? So these are the common units that we use. Just one thing, and I think it's coming up in the next slide, okay, is it's why we use SI units, okay? It's a very standardized thing, and as I said, I'm not going to answer the question I asked you before, but I'm going to tell you at least one thing about SI units, okay? And that is that SI units were kind of devised by scientists to kind of equalize everything, okay, so that we are, kind of on one page. So when I say that I am sending you 1 pound of something, then is your 1 pound equal to my 1 pound, right? So we need to make sure. Now, what are you going to do to measure that 1 pound that I gave you? You're going to have a scale as well. Now, whose scale is good, your scale or my scale, right? So you can see the issues here. So that's why there is something, that has to be standardized so that everybody follows those. And that, what we do then is then my instrument that I use for weighing 1 pound, and then your instrument that you use for weighing that 1 pound is calibrated. And once it's calibrated, then we know, okay, fine, we're okay now, all right? So that calibration, where does it come from? It comes from an international organization, which is kind of established in Paris. And from there, all the standardization and calibration happens, okay? So that's one thing I wanted to mention to you. And a lot of this, again, came about because of globalization, okay? Before that, every country had its own units. Everybody was measuring in their own in their own ways, and even the currency was all different. Currency is still different, but a lot of things were done quite differently, okay? So let's talk about SI units and the non-SI units. So SI units are actually all based on 10, which is what makes it really super easy to work with, okay? So when we talk about the non-SI units, all right, and here I've given you an example. So for example, in a foot, there are 12 inches, right? It's not 10 inches, so it's not based on 10. So anybody who's never worked with a foot before may not know that there are 12 inches, okay, in there. It's the same thing with a yard. There are 3 feet in a yard. 3 feet? Really? Who knew? Is it not 2? Is it 1? Is it 5? Like, how do you remember all of that stuff, right? So it's not like it's a standard number. The SI units, on the other hand, since they're all based on 10, all you have to do is either multiply by 10, 100,000, or divide by 10, 100,000 to come up with your unit. Remember, units are based on the fact that some units might be larger, some are smaller, okay? So for example, when you think about it, when you're looking at ounces and pounds, which is the larger unit? Pounds is the larger unit, not ounces, right? So a few many ounces is going to make a pound. I'm just saying a few many just to give you an idea that this is how I think, okay, that a few many ounces is going to make a pound. So with the non-SI unit, this kind of a thing is much harder to do, Okay, and when you're learning about units, and I'm not saying that everybody knows about units, not everybody knows about units, but when you go to school and when you learn about units, it's easier to learn in SI units because you have less numbers to remember. With the non-SI, you'll have a lot more numbers to remember. How many feet are in a mile? Who knows? How many inches then in a mile? Who knows? You know, that kind of a thing. You don't know because these are not standard numbers. But in SI, everything is about tens, how many zeros you can move, all right? So in SI unit, the smaller unit and the bigger unit, as I said, they don't have a completely different name. Okay, so for example, in the previous slide, you know, when we saw that the length is measured in meters, then meters is standard, okay? Whatever you're measuring, the meters is standard, but what happens is what the prefixes you put in front of it. So if you put a prefix of kilo, that makes it bigger. Milli makes it smaller. So we learned the prefixes, and those prefixes then can be used for any measurement. So you're not learning a whole set of different units for length and a whole different set for weight. You know, I mean, there's no pounds in distance, right? You don't measure distance in pounds. So, you know what I mean? This is kind of how it is. So when you're going in a distance, you're going larger number or a larger unit. How do you do that? Okay, what is bigger than miles? Yeah, think about it. Okay, something like that. So SI units are based on 10, non-SI not based on 10. So it's really harder. Okay, and for somebody who's not used the non-SI unit, it becomes really, really hard. Okay, to determine which is a bigger unit. Is it pounds? Is it inches? You know, between inches and miles, which one is a bigger unit? Now you know it because you've been dealing with it. Okay, so if I ask you what is a score, well, you know what a score is. Okay, you know what a decade is, right? Because decade, everybody knows, I think. You know what a century is. What's a score? Do we know what that is? I'm sure you do. But what I'm saying is we use all these different words, okay, for measurements. So here are the SI units, okay? I'm not going to go over the non-SI more than what I have, and then later on we'll do conversions, okay? But SI units I need to cover with you because this is something that I really need you to know, and this is what we use in chemistry. So you really need to know the SI units, okay? So as I said, we have prefixes, okay, for everything in whether you're measuring grams or whether you're measuring volume or you're measuring time, it doesn't matter. The prefix is the important thing, okay? So the way I look at things is that I start with the base unit. What's my base unit? Base unit is where 1 is going to be, okay? So 1 is the base. Anything smaller than 1 is going down. Anything larger than 1 is going up. Okay, so I wrote that for you over here. So hopefully that will make it easy. Now, all of these numbers over here, I've given them to you in exponents, although I know I have to cover exponents. Hopefully you know a little bit about them already. So for example, when you say 10 to the power of 3, you actually mean 1000, right? So 1 with 3 zeros, okay? A 10 with the power of 6 means that you're multiplying 10 by 6, right? Or not 10 by 6. 10 6 times, okay? So just like 10 to the power of 3 means 10 times 10 times 10, that's how you get the 3 zeros. So these are large numbers, right? If you're multiplying 10 6 times, that's a large number. Now 10 to the negative 1 is actually 1 over 10. 10 to the negative 2 is 1 over 10 times 10, which is 100. Then milli is 1 over 1000, right? So the negative numbers are smaller numbers. Okay, so first of all, this is, you know, the bigger and the larger numbers. Then the prefixes that I want to talk to you a little bit about. So the base unit is the base unit, whether it's grams or liters, that's the base unit. If you go higher, so for example, let's say that you have grams. After grams would be then kilograms. So kilogram then is a higher unit, megagrams is even bigger, but then milligram is a small unit. Okay, so as soon as you put milli in front of something, it becomes a small unit. So whether you're talking about millimeters or milligrams or milliseconds, you know you're talking about something that is 10 to the power of negative 3. Okay, so that's why prefixes are really good. Now, which prefixes do I really need you to know? Which are the common ones? Kilo, mega, giga, that's not too hard to remember. Okay, we all know about gigabytes, by now. So mega and kilo also should not be that hard for you. Deci, we do not use a whole lot. We use centi, milli, micro, and nano. Pico also sometimes we don't use because it's too small. Okay, 10 to the negative 12. We hardly ever talk about that small quantities. Okay, so you do need to know all of this. If you want to skip deci, that's fine. I can live with that. Okay, so how do you remember all of this? First of all, I'm very bad at mnemonics, so I'm really sorry I can't help you in there because I don't have a sing song here for you, okay, to remember this. I know there is one, but I don't know it, and I just remember things in a different way, okay? So that's kind of my thing. You come up with your thing on how to remember all of these, okay? But the main thing that you need to know is which is the bigger unit and which is the smaller, and by how much, okay? By how much. So I have given you two different ways of looking at things, and you look at it whichever way you want, provided it's correct. Okay, so remember, just because you're looking at something from a different point of view doesn't mean it's wrong. It's just a different point of view. Okay, that's all it is. Okay, so 1 kilogram has 1,000 grams, or 1 gram has 10 to the, and I have to correct this, oh my lord, 1 gram has 10 to the negative 3 kilogram. Okay, which means what? 1 gram has 1,000th of a kilogram. That's what that means. Okay, so there are two ways of looking at it. By the way, I just kind of let you know this is how I look at things. Okay, the first one is really how I look at it. I don't look at it this way because that 1 gram just kills me. Okay, that I cannot remember. So this is how I remember things. Just try to say it to yourself one time, and then hopefully that will help you out. Okay, so 1 milligram has 10 to the negative 3 grams. Okay, or the other way you can look is you can look at the larger quantity. Okay, so quantity meaning numbers. Okay, not the unit, the numbers. All right, so for example, 1 gram has 1,000 milligrams. You can look at that if you want. So actually, I should correct myself. I look at both of them in different ways, okay? Because I don't like negative numbers, okay? There are some things I can do with negative numbers really quickly, all right? And I do that, and I will do it in future, okay? But to understand this, maybe this portion will be helpful for you. Okay, if you look at on this side, look at the positive numbers. Okay, that might help you. So for example, 1 megagram has 10 to the power of 6 grams, whereas 1 gram has 10 to the power of 3 milligrams, which is 1,000. And you can write that out if you want to. Okay, all right, enough said. Moving on. So one of the things that you really have to do as you go on, okay, with chemistry is that you have to learn how to convert units. So converting units is like the big thing in the sense that you're converting two different kinds. One, you're going from SI to SI. You can also go, actually three things. You can go from SI to non-SI. You can go from non-SI to non-SI. Okay, so there are different kinds of conversions that you're going to have to do. When you convert units, you have to have what is called the conversion factor. If that conversion factor is not given to you, that means you're dealing with SI units, okay? Because for SI units, I generally don't give you the conversion factor. I need you to know all of those, okay? But for the non-SI units, I will give you the conversion factor. Non-SI to SI, I give you the conversion factor. And you have a chart, okay, in here that you can use, okay, for those conversion factors. I have no problem, okay, because I have so many other things for you to memorize. That is not one thing I need you to memorize, okay? Because I need you to memorize the SI units, okay? That's important. So when you're converting units, it could be a small thing, or it could be a large thing. It could be you might need 2 or 3 different calculations in order to get there. So we are going to do all of those conversion factors, okay? And then you have to be able to convert units as well, okay, as you go on. So before we go on into that, let's talk a little bit about scientific notations. As I said, there's just too much to do in this one. So A scientific notation is when you have something that you're designating 10 to the power of something, right? So just we saw that in the milligram and kilogram kind of thing also. But there is a very specific way how you write scientific notation, and that is that you have x times 10 to the power of n. And the main thing is that x is actually larger than 1 and smaller than 10. That's the big thing. So that's something you really have to mind, because I do look for that in your calculations. Okay, so x should be more than 1, less than 10. N can be positive or negative. That depends on whether you have a large number or a small number. Remember, when you have a negative number, it means it's a small number. What do you mean small number? Less than 1. Okay, when you have a large number, it means you have more than 10, okay, in there. So here are some examples. Okay, and if you know already all of this, you can go forward, you can skip all of this. So here is converting into scientific notations. Okay, so if you're looking at this number, this is a kind of small number, right? So you see the decimal point there, it's less than 1. And so what you do is you identify, okay, here is 623 at the end. So your decimal point has to go after 6, okay? Because remember, your x has to be larger than 1, less than 10. So it cannot be 62.3, it has to be 6.23. All right, so which means you got to move the decimal. So 1, 2, 3, 4. Now you're moving right. Now if you don't remember the right or left, it doesn't matter. Forget that. Okay. You can see that this is a small number, less than 1. If it is less than 1, it's going to be a negative exponent. Okay, so 6.23 times 10 to the negative 4. If it is a large number, then it's going to be a positive exponent. Again, 3.4, not 34.0. Okay, so you have to keep the number greater than 1 and less than 10. All right, so here 3.4 times 10 to the negative 5. How? Here is the imaginary decimal point because there is no number after here, so you can say that your decimal point is here. So 1, 2, 3, 4, 5. Okay, so that's how you get this number. So again, you just need to practice a little bit in order to get comfortable with the scientific notations. Okay, just follow the rules. So now just a little bit about significant figures, and significant figure is what we call something that has been measured. All right, so in some cases the measurement could be as simple as a count, right? So if you count, say, 4 pencils, okay, or that you have 12 eggs, that's significant because you measured those, you counted those, okay, one way or another. In lab, what happens is that sometimes when you count things or when you measure something, there can be a little bit of uncertainty, okay, that I don't know how to measure this one, okay, I know this much is for sure, okay, that I know it must be, like, you know, you remember directions, like I know I have to go this way, but after that I'm like, I don't remember, okay, where it is. That's kind of what this is, okay. So here's an example of a ruler, okay. And what we are talking about here in the ruler, if you can see, this is 7, right? So that's, we are measuring in centimeters. So this is 7 centimeters, and centimeters is actually, you have 10 millimeters in 1 centimeter. Okay, so each of these divisions here is a millimeter, and again 10 millimeters in a centimeter. So which means that each division is 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5 is this one. So this is the halfway point. Okay, so 0.6, 0.7. So you can see that the line here, the green line, is coming a little bit after 7. 0.7. So I got the 0.7. I'm like, okay, I know I can see that. But actually, if you look at the arrow line, that's just after the 0.7. So you should think, like, what do I do now? You know, do I have to measure it? And that number is actually something we estimate. Okay, so I wrote down 8. You might write down 5. And so depending on how we are looking at things, we might write a different number, and that is completely fine because all the scientists, they understand that that digit is estimated. Now, how do we all understand that? And that is because we know our measuring devices. Okay, so, and this is where experimentation can go a little bit here and there, because if your measuring device is not good, or if it is not standard, then we have problems with data. Okay, so you have to use good measuring devices. So here the measurement becomes 7.78. Okay. I haven't really told you how to look at significant figures. I'm just telling you how to measure something. Okay, so when you measure something, it becomes significant. So here, this is the significant figure we have. Now I'm going to go into what really is a significant figure. Okay, so first of all, measurement. Anything that's measured is significant. Even the estimated number is actually significant. Okay. So what are significant figures? Significant figures, even if you don't have any measurement that you're doing, if you're just given numbers and you're asked, okay, how many significant figures do you have? By the way, this is my shorthand right here, sig figs or SF for significant figures. If you're asked, what is the significant numbers over here, then these are the rules you're going to follow. Okay, so any numbers that you have that's non-zero, definitely significant. If you have a 0 between numbers, that is significant. If you have a 0 to the right, okay, of a number, then that's going to be not significant, depending on what that is. Okay, so we have to look for the decimal point actually. So here, if you see, I have not given you any decimal point here. So the left one here is, of course, definitely not significant. The right one here, is it significant or not significant? Technically, not significant. Okay, so then the zeros on the right after a decimal point, definitely significant. Okay, it takes a little practice again to recognize what is significant, what is not. It's not going to take you too long. Okay, but you just kind of have to look at this, and the ones that's going to bother you is this one for sure. Okay, so this one, actually, I think I should correct this one also. The 0 should not be red. It should be black, because the 0 is also not significant. Okay, so for example, if you have a number 10, so is that 0 significant in 10? No, it's not significant. Okay, so does it mean that your value is not 10? No, that's not what we're saying. Okay, we're just saying that you have one significant figure. That's all we're saying. So you can have a number of 100. But in that 100, again, the significant figure is 1. Now, how does 100 become significant, okay, for us? The only way 100 can become significant for us is if you put a decimal place, if you put a decimal point after the 0. So 100 and then decimal point, that is going to be 3 significant figures. Or you say there are 100 people. As soon as you say 100 people, that's a count. That's 3 significant figures. Okay, so unless that count is given to you or the decimal point is given to you, ignore that 0. Okay, that's how it works. Okay, so here are some examples for us, and you can see that how I'm counting my zeros. In the first one, you can see that I'm counting all the zeros because there is a decimal point, and the zeros before and after, they will all count, okay, in this. So 5 sig figs. In the next one, the first 0 does not count. That is what we call cosmetic 0, but you can call it whatever. But this is just 4 sig figs over here. In this case, I gave you different kinds of zeros. So this 0 gone, this 0 is gone, this 0 is significant. Okay, so 1, 2, 3, 4, you have 4 sig figs. And so then here you can see the last one I want to talk about. That one is only 2 significant figures. All right, because these zeros don't count, because there is no decimal point after this. Okay, so this one is just 2 sig figs. Okay, how to deal with significant figures in calculations. So the way you deal with it is you have 2 different kinds of rules. Okay, one for multiplication and division, one for addition and subtraction. For multiplication and division, you take the lowest sig fig of the number and then round it off. Okay, we're just going to talk about round off. Okay, just in a few minutes we'll talk about rounding off also. But you take the lowest sig fig and then you round off for the final answer. So here your sig figs 4, 3, and then 5 here. So which means your final answer has to be 3 significant figures. Okay, so no matter how far your calculator goes, eventually you got to bring it down to 3 significant figures. Okay, in case of addition and subtraction, it is the lowest number of decimal points. So here you have 1, 2, 3, 4 decimal points. Here you have 3 decimal points. So that's the lower one. So your final answer has to be in 3 decimal points. Okay, that's how it goes. So again, remember, multiplication, division, smallest number of sig figs, addition, subtraction, lowest decimal numbers, okay, that you have. Now rounding off, here we keep it simple. Look at the number next to wherever you need to round off. So you need to round off at the 3 sig figs. So you look at the 4th digit and then you see, is it 5 or more than 5? If it is 5 or more than 5, then you add 1 to the left number, okay? If it is less than 5, then you just drop it off. Okay, that's it. So that is how you do the rounding off. I don't think you will have any trouble, okay, rounding off. If you do, just let me know, send me a message, okay? All right, so that is significant figures and calculations, and here are some examples for you. I don't want to go through all of this, okay, but you can go through the calculations and then make sure that everything is working out for us. Some things that you can do for yourself, by the way, to make your life easy is that if you're coming up with really large numbers and you need to come up with, you know, a smaller number and a better way to write things, and, you know, it's not making any sense, just use exponents, okay? Whether you write your number like this or this, you know, exponents or no exponents, both are correct, okay? But when you have too many zeros, or when you have, you know, too many zeros before or after, it's just much easier to use exponents, okay, in those cases. So just be smart about how you're writing your answer, and learn the exponents also, okay? It's a good way to write numbers. Okay, so dimensional analysis now is how we set up our calculations step by step, so we can convert one unit into another, okay? Now this is done sequentially in the sense that what I do is I look at the unit I have first, and then I set it up the second and then third one, however number of steps you want to use for dimensional analysis, okay? And it sounds really like a big name, but you will see it's actually a very simple way of writing things. Now, I'm myself from India, and so we learned a little bit different method on how to do conversions from one unit to another. And I find dimensional analysis really very straightforward, okay, to do. Not that my way is harder, but dimensional analysis is certainly very straightforward, okay? So if you have not learned it, learn it. If you know the other method, you know, any other method for conversion factors, you can go ahead and use those for converting. I don't have any problems with anything. My thing is that you still need to learn dimensional analysis because later on we are going to use it. Okay, so before we get into that, here are your conversion factors. Whatever you need, hopefully you can find them here. If not, you can find on the internet, but usually for calculations and everything, I will give you the conversion factors that I need you to use, because sometimes I need you to focus on certain units, okay? So I will give you what numbers you need, okay, for conversions. Otherwise, use that chart, no problem, okay? All right, so here are some conversions, okay, that you can do. And so this one is SI to SI conversion, okay, as you can see from here. And remember, I said SI to SI, you have to remember those conversion factors yourself, all right? So the first one is going from grams to kilograms. And so here is my thinking, like you have to remember whether kilograms is the larger unit or the smaller unit, okay? So similarly, going from liters to milliliters, what is milli? Milli is a larger unit or a smaller unit, okay? That helps me to formulate my strategy for calculation. It also helps me to check if my final answer is correct or not, okay? You don't just randomly multiply things and think, oh yeah, this has to be correct, okay? And then not check your answer and think logically, like, does this make sense, you know? And the thing is, it will make sense to you only when you understand the units, whether the units are larger or smaller, Okay, so for example, when you look at 230.2 grams going to kilograms, so kilogram is a larger unit, which means by the time I'm done with this calculation, I should have a smaller number because I have 1,000 grams in a kilogram. Okay, so the final answer should be a smaller number. Milliliters is a smaller unit. Okay, so if it is a smaller unit, that means I'm going to have a larger number as an answer. Okay, so you have to kind of start thinking like that in your brain, and that will help you to see if your final answer is correct or not. Okay, so what that is also going to do is it will help you set up your calculation. Okay, so when you set up this, so the first one, 230.2 grams times, this is dimensional analysis, by the way. So you set up grams up here, so grams should be down there. So when you divide grams by grams, you cancel that out, and kilograms is on the top. This is what I'm talking about. You should know what numbers to put in here. If you put 1,000 on the top and 1 at the bottom, you're going to have trouble, right? So the 10 to the negative 3, the 10 to the power of 3, you need to know where to put those, okay? So if you put 10 to the negative 3 down here, you're going to get a wrong answer, okay, for that. And then you will just leave it because you might think, oh, there's the 10 to the negative 3 grams in a kilogram, but that's not true, okay? There's actually 1,000 grams in a kilogram. So you really need to go to your SI units and make sure you learn them in a way that will help you remember the bigger and the smaller units. Okay, so going from liters to milliliters. So liters is what you're starting with. So liters should be down here, and then the milliliters should be on the top. Remember, this is your conversion factor, 1,000 milliliters in a liter. Okay, that's how it goes. Now, in this case, what are we doing here? We're going from nanometers to kilometers, okay? So nanometers is a small unit, nano, and kilo is a larger unit, okay? So in the middle, if you remember, kilo was here, and the base unit was here, and then nano was way down here. Nano is -9, so it was way down here. What I do for my calculations is I always go to my base unit. Once I'm at my base unit, then I can go top, bottom, wherever I need to go, okay? Because I am like that. That's what I do. So for nanometers, I will convert first to meters. So I know in 1 meter, I have 10 to the power of 9 nanometers. So nanometers, nanometers. So I'm left with meters. Then I'm going to convert my meters into kilometers. In 1 kilometer, I have 1,000 meters. So then I will go ahead and set up my calculations. Okay, now you have to learn how to do exponents on your calculator. If you need help with that, you need to go to the math lab and see if they can help you set up your calculator, or come and see me sometime. Okay, and I can see if I can work your calculator, because you don't want to be putting 9 zeros in your calculator. You want to learn how to use exponents on your calculator. Okay, here are some other conversions. So this one is a non-SI to SI, meaning going from inches to meters. The conversion factor, however, that's given to us is inches to centimeters, not to meters, to centimeters, which means that I gotta convert these inches to centimeter first, and then I have to convert it to meters. Okay, so what are the conversions factors that I need? Well, I've been given one already, which is 2.54 centimeter is equal to 1 inch. And then I also know that in 1 meter, I have 100 centimeter. Centipede, right? Centi is 100. So 100 centimeters in 1 meter. If you write it this way also, things become a little bit easier. Okay, and I will tell you why as we set up. So 11.10 inch, we are starting with that. And then inch goes down here, centimeter goes up here. Don't put the numbers yet if you don't want to. And then you have to do one more conversion because you have centimeters up there now. So centimeter goes down here, and then meters on the top. Okay, now you can go back and put all the numbers. How do you put the numbers? In the inch, you put the number in front of the inch. For centimeters, whatever number is, you put that in front of it. Okay, the same thing here. For meters, the number was 1. For centimeters, the number was 100. Okay, so there is a value in writing your numbers like this, but sometimes in exams and all, we don't have enough time, right, to write it out like this. So you have to kind of just set up this and be fine with it. Okay, so you have to know that in 1 centimeter, you have 100 centimeters. Carry out the calculation. I have crossed out the units to show you how beautiful it looks when you cross out the units and you're left with the one that you need, okay, which was meters. And then once you have your answer, you make sure that you calculate to the right sig figs, which here is 4 significant figures. So your answer should be in 4 sig figs as well. Okay, so make sure you round off properly. Whatever significant figures you have in your conversion factors do not count. Okay, so 2.54, that doesn't count. Okay, as 3 sig figs, I mean it does, but not for our calculation because our data is 11.1. Okay, so that's what we're going to use for our final answer. Okay, so you can see how I am setting up my conversion. So again here, just go through this and make sure you learn how to set up, step by step on how to do these calculations. Okay, more problems. Again, all of these, there's no point in me going through all of this, but just go again through all of these problems to make sure you understand how to set up these things. The one over here, by the way, number C, is I'm doing 2 conversions. Okay, I'm going from kilometer per hour to miles per minute. Okay, so I'm doing 2 conversions. By the way, the hours to minute conversion factor is not given because everybody knows there are 60 seconds in 1 minute and then 60 minutes in 1 hour. So that conversion factor is not given to you. The mile to meter is given to you. So you have to convert the meters to kilometers yourself. Okay, so this one becomes a little bit long calculation. But again, if you start by setting up your units properly, then you just go step by step in order to get to the final answer. Okay, so take your time and go through these calculations, and again, just let me know if you run into any issues. Okay, so a couple other words to talk about here, which is accuracy and precision, and these are easy words but really important. So accuracy is when your measurement is actually close to what it is supposed to be. Okay, so for example, if I say I'm 50 years old, then if you have guessed like, oh, she's, maybe, around about 50, so around about 50 means what? Like 50, maybe a month or 2 older or younger, right? That would be sort of accurate. Precision is when you measure something and you get the same number, but it's not correct. Okay, so it's not the actual value, but you're getting the same number, okay, again and again. So for example, if you're trying to weigh something, on a balance, and you keep weighing like, I don't know, a beaker. Okay, so if you're weighing a beaker, you keep getting the same number over and over again, then it's precise. Okay, you will not know its accuracy until you know the actual weight of the beaker. Okay, so there is a value to both. Okay, the best thing would be if you have both accuracy and precision. Okay, that's the best kind of data. But sometimes even if you have good precision, that is also good, okay, because in some cases your data may still be valid if it is precise. But if you have neither accuracy nor precision, that's the time we need to either calibrate our instruments or we need to change our technique. Something is wrong somewhere at that point. So here is an example of accuracy and precision of data. So a beaker, oh, here is a beaker. So beaker is weighed 3 times and you can collect the following data. So here is 22, 22, 22, but it's 0.56, 0.52, and 0.58. So at this point, the data that we've collected is actually precise, but not accurate. I shouldn't say not accurate, but accuracy cannot be determined, right? Because we don't know what the weight of the beaker is supposed to be. So here the second example, density of lead is 11.34, and in the lab it was calculated and found 9.34, 9.28, 9.05. So it's it's not quite precise, because 9.34 and 9.05 is actually quite far from each other, and it is really far from what it is supposed to be, right? It's supposed to be 11.34 and now it's 9. Forget it. Okay, so time to change those instruments there. Okay, so it's neither precise nor accurate, okay, at this point. So this is also a very important thing when you do experiments in the lab. We look for everything in there. We look for precision also, and we look for accuracy in your data collection. So that's the end. I know this was really long. I'm really sorry. Hopefully you can break it into pieces and do it in small portions as well. Okay, but a lot to learn in this one portion. Okay, sorry.